So IDE is comprised of lots of software. So first thing is our notepad to write the code. The very famous is the notepad++ or VS Code also we use. The compiler, assembler compiles our source file, .c file, .h file, .s file. We will see how this compiler works. What is the linker? When the compiler and assembler runs, for each source file, the individual object file got created. What linker does is it links all the different object files. The machine instruction is got created basically in the obj file. Two things it does. First thing is that it links the object files. Maybe you have the external libraries, it will link everything together, and linker will also decide that which part of code will go at which place in the memory. This address area your code will go, this address area your data will go, this address area is your heap, this address area is your stack. So needed files in the ARM based controller, we have something called a startup file. Startup file is a very important file. It's more close to the hardware because when our microcontroller boots up, so startup file is the first file which executes. In the startup file we have many hardware related things. We will design our own startup file. First program to hit basically after the reset. So reset handler will be there, interrupt configurations will be there, stack related configurations will be there, RAM initialization, code copy from the flash memory to the RAM. Since it is more close to hardware, we prefer it to write into the assembly language, hex code. Extension is .s. Now what is a debugger? Debugger enables you to debug your code. Suppose if your code is not behaving in a way you want, you are not getting some output, some reset is happening, how you will find out that issue? If the project is very small, you can understand the issue. When you are working in the industry, projects are really big. One source codes will be of 2,000 lines. In that scenario, it is not possible to debug just by seeing the code. We do the debugging based on the program execution. So step by step we execute the program, and sometimes we can put the breakpoint also. If we will put the breakpoint and the execution will come till that breakpoint, then it will stop there. We use it to debug the code. What is the flashing tool? So all the development activity we do in our PC, and finally a binary file got generated. Now that executable file, that where it has to run into the microcontroller, not in the PC. So we call it the cross compiling or cross platform development. So in one platform we are developing everything, but that is running into the another platform. And if you are writing simple C programming, that is a platform development to flash binary into microcontroller. For the we will use the notepad++. For the compiler as well as for the linker also we will use the ARM GCC compiler. Startup file we are going to write. We have a open source debugger which is GD debugger. Flashing tool STM Programmer we are going to use. In the needed file we have a startup file, and also I missed one thing, we have a linker file also .ld. So this is also one important file which is being used in the project. I will explain you in the detail in the later part what is the use of this. What are the hardware so we need? Mostly we need two hardware. One is the evaluation module. One debugger we need. It's not the software debugger, it's the hardware debugger. This is the board. This is the EVM. Now with this evaluation module we need a hardware debugger also. This is the debugger. This debugger is also from the ST Microelectronics. The name of this debugger is basically ST-Link V2. How the debugger and the EVM work. Here you have your EVM, you have a small debugger. Suppose here is your PC. One end of the debugger goes to your PC. One end of the debugger goes to the microcontroller or the EVM evaluation module. Ultimately it connects to the microcontroller only. So this is how the connection happens. So if I will show you here how it will happen is, this is one wire I have, one end, this one, okay. Another end is the USB, it will go to the PC. How we will connect the debugger and the board? We have a ribbon cable for this. So we are going to connect this ribbon cable, and then we are going to connect this debugger. That's how the connection will happen. In some evaluation module, we don't really need an external debugger. Debugger is inbuilt into the evaluation module. For example, this TIVA-C series board we have. Two controllers you will be able to see. One is this one and another is this one. So this one is the main microcontroller and this one is the debugger part.